Hey guys, so what we're going to do is we're going to be looking at some double angle identities and using these to evaluate problems like the two that are shown below here. So these are important for you to note. You'll definitely want to have these down. They are given to you in your IB math reference book, but I would like for you to have them here. So here they are. They're just formulas that we can use. Notice how cosine 2x has three formulas. Reason being is because I can use the this trig identity to replace sine squared with, say, cosine squared, and then I would generate the rest of these guys. So it just depends on what you're given. So what I mean by that is if we are starting here with sine theta equals -7/25. They're also telling me the quadrant that I'm in, which is helpful. So 3 pi over 2, between 3 pi over 2 and 2 pi, that is in this quadrant where cosine theta is positive, right? So it's nice that they give us that information. Last but not least, I just have to pick one of those formulas. And since they gave me sine, then I'm just going to sub into the one that makes use of solely sine, which would be this one. So cosine of 2 theta equals 1 minus 2 sine squared, which is -7/25 squared. Okay, so all I'm doing, guys, is I'm taking this -7/25 and subbing it in for sine, and then it tells me I have to square it. This is going to be kind of gross, but that's fine. So my answer for this one would be cosine of 2 theta, and you could type this in on your calculator, um, is what, 527 over 625. Those numbers are pretty high, but that's it. Okay, done. Um, Tangent's a little more unique. So here we have tangent equals 3/4, and my angle is between pi and 3 pi over 2. So here's pi. So we're in this quadrant, quadrant 3. Okay, so that's what it's telling us. We're in quadrant 3. So guys, when I'm trying to get tangent of 2 theta, now I need tangent of 2 theta is equal to sine of that angle over cosine. So notice, guys, how I'm going to need both of these equations, okay? The nice thing about tangent, guys, we know that tangent is sine over cosine. So I have sine of theta is what's in my numerator, which is 3. Cosine of regular theta is what's in my denominator, which is 4, which makes coming in here, guys, and subbing into these equations so much easier. So sine of 2x, I have to sub into this top guy. So I've got 2 sine of x, which is 3, times cosine of x, which is 4, over. Now, cosine of 2x, I can pick any of these. It does not matter which because I happen to have both sine and cosine. I'll just pick the first one. So that says cosine squared. So cosine is 4 and I need to square that. So that's 16 minus sine squared, 3 squared, which is 9. Okay, so now you just have to come through and do the math. So 16 minus 9, that's a nice 7. 2 times 3 is 6, times 4 is 24. So tangent of 2 theta is 24. Done. Oh, one thing I guess I should have brought up that I didn't point out until just now. When I'm looking at tangent, this is telling me that sine and cosine are negative. So actually, I should have made both of these negative because we're in quadrant 3. Um, so how would that change this guy? Luckily, not much, because this would be a negative, this would be a negative. All of these guys would still multiply out to be positive. And since I'm squaring both of these items, -4 squared is positive 16, and -9 squared is positive, or -3 squared is 9. So this worked out okay, and this is my final answer. All right, that was fun.